Welcome to the manipulation of power series by me. To start, what is the power series? If x is a variable, then an infinite series of the following form is called a power series, where the series is centered at c and c is constant. As you can see, every factor is multiplied by x minus c to the nth power, where n is a natural number starting at 0, 1, or technically anything, but usually 0 or 1. Fun fact, the creator of the power series in the Western world was the English mathematician Isaac Newton. Power series can also be expanded into its respective derivative and integral functions in this way. The top power series just is what's expanded when you take the derivative of f of x, which can be first derivative, second derivative, etc. Same thing with the integral, and the bottom is what it's expanded into. Why do we use power series? If we use power series, we can use them to expand functions using only the functions of addition, subtraction, multiplication, and division. The more terms there are in a power series, the more accurate the power series gets to its parent function. So as you can see, the function cosine of x is the black line that you can see, and every graph on top of it, blue, pink, and red, are just the power series, but with more and more terms representing them. As you can see, blue is the least amount of terms, and red is the most amount of terms, and red is the most accurate to the function. And if you have an infinite amount of terms, then the two functions are identical. Fun fact, the power series is what's used to program our calculators. The radius interval of convergence are also some things we need to know. So to start, x minus c is in every power series where c is defined as the center. Power series where c is equal to 0 are often expanded into Maclaurin polynomials, and power series where c is equal to any other constant is often expanded into Taylor polynomials. In these such series, the series always converge at the center, meaning that they can converge somewhere else, but they will always converge where x is equal to c. Another part of the power series is that the radius of convergence is the distance from the center of the series in which the series can converge. For example, if c is equal to 0 and arc is equal to 2, then the series converges between -2 and 2. This brings us to the interval of convergence, which is the range in which the series can converge, defined by c minus r to c plus r. If it's in parentheses, that means greater than or less than, which means that endpoints are excluded, and brackets mean that they are included. In order to determine whether these endpoints are included in the interval of convergence, you need to plug them into the general term and determine if they converge or diverge using the convergence test. Now, that's pretty much it, but before we end, there's a quick question that you can solve if you want. Just figure out if it's true or false, and you can pause the video. Alright, revealing the answer in 3, 2, 1. If you answered true, you'd be correct. Figure out why. Thank you, that's all for today. Goodbye.